Okay, here we are on the back side, and this is one of those really famous circles that has everything on it, and we're going to kind of start putting it together. We're going to leave off the coordinates for the time being. So basically our purpose today, because this is what we're working with a lot, is to fill in all the degrees and the equivalent radian measures and see if we can find maybe some patterns that are going to make it helpful for us. So let's do the easy ones first. Like that is 0 degrees, which is the same as 0 radians. And then I'm going to come all the way over to here, right? Rotate all the way over to here. That is 180 degrees. Same thing as pi. Just have to memorize that for sure. All right. Halfway from 0 to 180 is 90, which means halfway from 0 to pi radians is pi over 2 radians. And now if I think about going up 90 degrees, and then I add another 90 to get to 180, I'm going to add another 90 to get down to 270. Or pi over 2, pi, 3 pi over 2 for the radians. Right? This is like 1.5 pi's, I guess. And then all the way back around is 360 degrees or 2 pi. All right, so one thing I kind of liked as I was researching good ways to remember this, I'm going to go ahead and jump to this halfway angle right here. Like if I rotate from here up to here, it's halfway between 0 and 90 degrees, which puts it at 45 degrees. And one thing that you could do is just memorize 45 degrees goes to pi over 4, or look at the radians, right? If it's 0 to pi over 2, halfway between, 0 and a half is 1/4. And then what is nice is to maybe do some color coding. I'm just going to trace that X there. And, oh, I jumped ahead of myself. Let's see. And I'm going to just kind of keep going around, thinking about adding 45 degrees each time I split a quadrant in half. So that was 45, 90. If I add another 45, that takes me here to 135. All right. Add another 45. That would take me to 180. Another 45 would be 225. And another 45 would be 270. Another 45 would be 315. And a final 45 would take me all the way back up to 360. So I was going to just highlight these two right here. So one observation, anytime you're at these halfway marks, the denominator for radians is always going to be a 4. It'll always be the same. Okay. And you can kind of just count, by quarter pies. So this is 1/4 pi, or maybe I should say 1 pi over 4, 2 pi over 4, which reduces to pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4 brings us all the way back around to 2 pi. Okay, next observation is that this first quadrant right here is kind of cut into thirds. There's 1/3 from there to there, 1/3 from there to there, and another third from there to there. All right, so if I take my 90 degrees in degrees and I divide it into thirds, I would have 30 degrees, right? That would rise up from here to here. And then I would have another 30 degrees. So that would take it up to 60. And then another 30 degrees to 90. And I can just keep adding 30s around as I hit each of these 1/3 markers. So 90 plus 30 would be 120. Plus another 30, right? I'm skipping over the 45 degree family ones. 150. 180, plus another 30 would be 210, 240, 50, 60, 270. This would be 300, plus another 30 would be 330, plus another 30 takes me back to 360. All right, and now to maybe color code these guys, because they will also, their radian measures will also all have the same denominator. So you could take 1/3 of pi over 2. Basically, that means that you take pi over 2 and you times it by 1/3, and you get pi over 6. So this would be pi over 6. Okay. So if I wanted to count by pi over 6's, then I could hit all of the rest of the angles. So this would be a pi over 6. This would be 2 pi over 6, right? 2 pi over 6. But that reduces down to pi over 3. So I have a different denominator here than I do on this one. Okay. Let's see. I didn't color code this, but right. These denominators for the radians, from here to here and here to here, they should all have the same denominators. And they should all have denominators of 3's. All right. So that was 2 pi over 6, 3 pi over 6, 4 pi over 6, which is 2 pi over 3, 5 pi over 6, no reducing needed, 6 pi over 6 takes me back around to pi, right? 7 pi over 6, go to the next 30 degrees, 8 pi over 6, which is 4 pi over 3, 9 pi over 6, already reduced here, 10 pi over 6, which is 10 over 6 is 5 pi over 3, so that was 10 pi over 6, 11 pi over 6, and then this would be 12 pi over 6. All right, so just observation that on this diagonal you have the same denominator each time. Right? On this diagonal you have same denominator in your radian measures. Okay, I think I might have been off the screen a little bit. I apologize. Okay, we are going to save the coordinates probably for a different video because there's more stuff that happens in